Electric vehicle enthusiasts, beware. The most expensive brick on the block, Tesla shares, are lower ahead of the company's announcement. Meanwhile, GM has just unveiled their all-new zero-emission engine that could render both electric and internal combustion vehicles obsolete. This radical new technology is being hailed as the next revolution in the automotive world, promising to drive us toward a completely eco-friendly future of cars. Without wasting any time, let's dive into this groundbreaking innovation as GM CEO introduces an engine that could change the world. But what exactly is this new technology? GM has been searching for an alternative to EVs for years, and their efforts have led them to compressed air technology. Compressed air was used in the 19th century, primarily in mine locomotives and trams in European cities like Paris. However, the technology was abandoned in favor of internal combustion engines due to their superior power. In the early 2010s, the French car manufacturer Peugeot saw potential in combining compressed air with internal combustion engines to create a hybrid technology that retained eco-friendliness without needing a battery. Although these prototypes didn't progress far, they sparked interest in the automotive industry, particularly from GM. GM recognized the potential of compressed air vehicles but understood that significant development was needed to compete with internal combustion engines and the rising popularity of EVs. As a result, GM began researching and developing compressed air technology alongside their work on EVs and traditional engines. So, how do compressed air vehicles function? Unlike conventional piston-driven engines or electric motors, compressed air vehicles use pneumatic engines. These engines are mechanically similar to internal combustion engines, utilizing pistons connected to springs. Instead of relying on explosions to create motion, pneumatic engines introduce compressed air into the chamber, increasing pressure to push the piston. The air is then released, and the spring returns the piston to its original position, completing the cycle. This similarity to internal combustion engines allows GM to leverage existing technical solutions, shortening the development cycle. The benefits of compressed air engines are significant. They are 100% pollution-free, relying solely on pressurized air, which eliminates environmental damage during operation. This solves one of the biggest issues with combustion engines, direct pollution. Compressed air engines also outperform EVs in terms of cost, as they require no rare earth materials and are cheaper to produce. Additionally, powering EVs isn't entirely green, as the grid still relies heavily on fossil fuels. Compressed air engines are also more cost-effective to produce than internal combustion engines, as they endure lower pressures, reducing the need for hardened steel. Running costs are another advantage, as compressed air is cheaper and more accessible than fuel or electricity. These engines are also future-proof, as they use pressurized air that remains unchanged after use. However, compressed air engines have drawbacks that have limited their widespread adoption. One major issue is their lack of power. Compressed air has low energy density, resulting in low torque and high RPMs, which can lead to excessive wear. Lubrication is also challenging, as the engines don't use liquid propellants. Additionally, compressed air engines are inefficient, with most prototypes offering a range of only 140 kilometers, less than 100 miles, making them impractical for long trips. Safety is another concern, as early prototypes used steel air tanks that were heavy and prone to explosions if damaged. GM has been working to address these issues. They've introduced high-pressure air tanks to increase power, achieving performance comparable to gasoline engines. They've also extended the vehicle's range by integrating the chassis as a compressed air reservoir, using lightweight, reinforced materials to improve safety and efficiency. These advancements suggest that compressed air engines could enter mass production within the next few years. GM's dedication to this technology stems from their recognition that internal combustion engines are nearing their end, and they lack a strong foothold in the EV market. By pioneering compressed air vehicles, GM aims to dominate a new market, rendering both combustion engines and EVs obsolete. This isn't the first time compressed air technology has been explored. Peugeot developed a hybrid version of their 2008 crossover, combining internal combustion with compressed air to achieve 120 miles per gallon. Despite promising results, Peugeot abandoned the project, citing profitability concerns. Some speculate that pressure from oil companies played a role, as widespread adoption of such technology could threaten their profits. A similar fate befell Stanley Allen Meyer, who invented a water fuel cell in the mid-90s. After resisting pressure from oil companies, Meyer died under suspicious circumstances, and his prototypes vanished. This history suggests that powerful interests may resist disruptive technologies. GM, if you're listening, continue developing this engine in secrecy to avoid the fate of Peugeot's hybrid. Was Stanley Allen Meyer. The potential for compressed air technology to revolutionize the automotive industry is immense, but its success may depend on navigating the challenges posed by entrenched interests. The story of compressed air technology and its potential to disrupt the automotive industry is a fascinating one, filled with innovation, challenges, and the ever-present influence of powerful interests. GM's pursuit of this technology represents a bold step toward a sustainable future, but it also highlights the complexities of introducing groundbreaking innovations in a market dominated by established players and traditional technologies. GM's commitment to compressed air engines is not just about creating a new type of vehicle. It's about redefining the future of transportation. By addressing the limitations of earlier prototypes, such as power, range, and safety, GM is positioning itself as a leader in the next wave of automotive innovation. The integration of high-pressure air tanks and the use of advanced materials like fiber-reinforced thermoplastics demonstrate the company's dedication to overcoming the technical hurdles that have historically held back compressed air technology. However, the road to mass adoption is fraught with challenges. Beyond the technical and engineering obstacles, there are broader economic and political factors at play. The automotive industry is deeply intertwined with the fossil fuel sector, and any technology that threatens the status quo is likely to face resistance. The cautionary tale of Stanley Allen Meyer and the mysterious abandonment of Peugeot's hybrid project serve as stark reminders of the potential backlash from powerful entities with vested interests in maintaining the current system. For GM, the key to success lies in balancing innovation with strategic discretion. By continuing to develop compressed air technology in a controlled and confidential manner, GM can mitigate the risks of external interference while refining the technology to a point where it becomes commercially viable. The company's ability to leverage its existing expertise in internal combustion engines and its growing experience with EVs gives it a unique advantage in bringing compressed air vehicles to market. Moreover, the environmental and economic benefits of compressed air engines cannot be overstated. In a world increasingly focused on sustainability, a technology that offers zero emissions, low production costs, and minimal reliance on rare materials has the potential to capture the imagination of consumers and policymakers alike. If GM can successfully navigate the challenges ahead, compressed air vehicles could become a cornerstone of the green transportation revolution. In conclusion, GM's compressed air engine represents a bold and visionary step toward a cleaner, more sustainable future. While the path to widespread adoption is uncertain, the potential rewards are immense. By learning from the past and addressing the technical, economic, and political challenges head-on, GM has the opportunity to not only transform the automotive industry, but also to play a pivotal role in shaping a more sustainable world. The stakes are high, but so are the possibilities. As GM continues to push the boundaries of innovation, the world will be watching to see if compressed air technology can truly become the next revolution in transportation.